Hello everyone, can you hear me? Can anyone please confirm? Am I audible to all of you?
Yeah, we can.
Yeah. Thank you so much. And we there is a small glitch from our team, so we are sorry. It's my apologies. So yeah, let me start it now. So welcome to all of you to today's webinar on geotechnical engineering. First of all, I would like to thanks to 𝗏𝗏𝗺𝗀𝗃 and Ganesh sir and for giving his time, and so we are very happy to have you here, and also our 𝗚𝗏𝗃 sir. So we are very happy to having you both here, sir. So hope so I think time is running up, so we will start the session. So hope sir, can I make you a host?
Yeah, sure.
Just to give me a minute, sir, actually. So one small, just give me a minute, let me make your. Sir, we are giving a permission to you, so that you can start our meet today. So just give me 2 minutes, sir. So we are giving here.
Okay, sure. Okay.
Sir, are you able to share your screen? Can you please check it?
Let me try. Okay.
Yeah, please.
Yes, I think I can.
Yeah, you can. You can start the studio session, sir. Yeah, thank you, sir.
Okay. So, can you see the full screen, everyone?
Yes, sir.
Okay, thank you. So, good morning, everyone, and thank you, Mr. Reddy. So, I'm 𝗏𝗏𝗃𝗃. So today we are going to see about geotechnical site investigation and report preparation. So it is an overview. So by the end of this session, you will know what is site investigation and what is the purpose and why it is important and how we proceed on the site, and in the end how we are going to prepare the report, which is very essential. After we do all the site works, if we don't have the data, will be scattered everywhere. So then in the end, how we will gather all this information in terms of report, and how we have to align the report will give you one a good idea. Okay, that's what you will know in this today's session. Okay, so let me start with the geotechnical projects. So how it starts? So let's say I am client. I have a big plot of land. I want to construct an apartment. Okay, so in some portion I want to construct an apartment of, let us say, 10-story or 12-story building. In some other portion of my plot, I want to construct a villa and swimming pool. Okay, so now I'm approaching my engineer, or approaching engineer. So I'm asking, okay, I want to construct what is your suggestions? So then engineer will say, so in order to construct, we have to know what is the foundation material. So then in order to know the soil properties of that particular land, we need to proceed with geotechnical investigation. Okay, just by seeing, we cannot determine the soil property. We have to do some testing. We have to collect the sample and analyze, and we have to do some test on the site itself. Okay, so first we propose, okay, what project it is. That's why first we do what is a project description. It's a construction of apartment. Okay, first we do phase by phase. First we go for the like apartment construction, geotechnical for apartments. So this project is mainly for the geotechnical investigation for construction of apartments. Now, once we know what is the project description, we need to prepare the bid document. Now, either if the engineer have the geotechnical knowledge, he can define what are the geotechnical tests need to be performed on site. So let us say we will talk about what are the different like boreholes or how many boreholes are required. Trial pits are required. How many trial pits are required? So this and what are the tests need to be done. Then so how many tests need to be done? So this will be as a bill of quantity. This will be compiled and which standard they have to follow. Everything will be in the bid document. Then once the bid document are ready, it will be sent it to the geotechnical contractors. So whoever within that premises or within that within that particular region, the engineers, they will send on behalf of the client, they will send it to the geotechnical contractors. Then they will give their prices for this test. That will be a tender submission. Once the submission is done, then depending on the whoever is lower, and also not only who is low, and in the technical perspective, who is giving the better options as well. So based on their experience in the proposal, they may propose something different and economical, which is economical for the project also. If something, whichever is a benefit for the client, accordingly, the tender, whoever submitted the tender in economical and technical perspective, the bid will be selected. Once it is selected, that particular contractor will do the site investigation. And very importantly, they will do the site investigation as per the project scope of works, which is defined in the bid document. Okay, then if there is any additional investigation required, that the engineer will tell based on the site investigation have been performed. While investigation is going on itself, the engineer can propose something. Okay, then based on these collective informations, the report will be prepared. It is called geotechnical report. Then it can be either factual or interpretative report. Then I think someone switch on the mic. Can you please mute? Okay. So then monitoring. What is monitoring? Let's say you gave the geotechnical report. You are starting the construction based on this geotechnical report. You have to monitor, is it reflecting the as it is given in the geotechnical report, or it is something big variation is coming? Or let us say you in the report you mentioned for this particular structure, this foundation, it is within the permissible limit of settlement. Now, if it is exceeding that level or exceeding that limit, immediately you have to reconsider with the geotechnical team what's happening in this particular zone. So like that, you have to monitor, like a slope stability, is there any sliding is happening, or is there any change in the whatever it is given in the geotechnical report? And while we are doing the construction, what are the any other new difficulties you are facing? So you have to monitor, is everything okay? So this is called monitoring. So overall, this is how it start and end the geotechnical project. It start with a well-defined project description, then bid document and the tender submission, then site investigation, then geotechnical report and monitor. So this is the overall view for your understanding. Now let's start with the site investigation. What is now in the site investigation, mainly it is to know what is the surface condition and what is the subsurface condition. Now in the generally, whatever we are planning to construct, we are going to construct either on the soil or on the rock. So this soil, it can be either transported soil or native soil. The transported soil, it is it can be like it can be transported from alluvium, like transported by water, which is called alluvium, or it can be like colluvium soil if it is near to the mountainous region. In the foothill of mountains, all the deposits from the hill, it will roll down and deposit in the foothills. That is called colluvium soil. Or it can be by this place, maybe there was a lake in this particular region. So now it can be dry. So if the deposits happen due to the lake, small fine grain, it will deposited, that is called lacustrine deposit. So, so it can be either which or wind deposit. We call it as a aeolian deposit. So it can be any kind of deposit deposited by transported material, or it can be native soil. What is native soil? Normally we know that whatever the soil we see, all it is originated from the rock. Okay, the rock slowly becomes soil in general, in simple term. So if it is not disturbed, then the rock itself, it is converted into soil. If we are getting that kind of soil in the project site, that is called native soil. In other terms, we can call it as a residual soil. Why we call it residual soil? We can see the remnants of that rock. Okay, so in general, residual soil is much better for construction. Okay, so all then we have to know that based on site investigation, we have to know the soil properties. Okay, what properties? So we will know cohesion, and cohesion is intermolecular attraction between the soil particles. Then angle of internal friction, or permeability, compressibility of the soil. Based on the compressibility, we can say if we build any building over there, how much settlement it can happen, how much it will compress. That is called compressibility. And if you are constructing the dam, we need to know the permeability of the soil or permeability of the rock. So how we can determine the permeability? Based on the field test, based on the site investigation. Okay, so all these parameters, soil properties, it can be determined based on the site investigation. Based on all these parameters, we can design the foundation. That is the main that is the main concept of site investigation. Okay, so these are just introduction of the site investigation. Now, objectives. What is the purpose? I just mentioned. So to evaluate the suitability of the proposed project. So let us say if we are going to construct any kind of construction, is that site is suitable for this project or not? We can determine based on the site investigation. Then what type of foundation we can do? It can be shallow foundation or deep foundation. It is shallow foundation, what type of foundation we are going to do, and what depth we are going to do the foundation. This we can determine by the site investigation. Then evaluation of bearing capacity. We, especially for any foundation, we need to know bearing capacity and the settlement characteristics of the soil. So if we are going to construct, let us say our foundation pressure is going to be 200 kPa, and if the soil bearing pressure or bearing capacity, it is 150 kPa. Of course, you cannot build that structure in that particular soil. Either you can see, can you rearrange your structure, or can you redesign your structure, or you should replace the soil, or can you replace the soil with soil with good properties? That we can determine. Same with the settlement characteristics. And also, what is the groundwater table in this particular region? Now, the groundwater table is very important, because if the groundwater is so deep, no problem. If the groundwater is very shallow, or if it above the foundation, then it can reduce the bearing capacity in a much tremendous way. Even it can reduce the bearing capacity up to 50% of the bearing capacity of the particular soil. So it can affect the bearing capacity. So that's why groundwater table is very important. Then is there any potential issues? Like if the site is under expansive clay, you have to take proper precautionary measures after the construction. Of course, you have to replace the soil, but at the same time, surrounding the foundation also, we have to make sure it is not going to affect the foundation in future. Okay, so how during and after construction, how it can affect the project site and the future construction, we have to see. Then we will know what are the potential geotechnical issues. Like, let us say if it is near to the slope, we can know, is there any landslide is it landslide prone area, or will we get any landslide in future, or is there any possibility, or is there any drainage is passing in that one? So should we are we going to block the drainage? Definitely you are not going to block the drainage, because it will affect your foundation or your structure later. So should we do any diversions? How can we do the diversions? Is it economical or not? Okay, in that way you can decide. So that is also the purpose of site investigation. And also based on this based on all the site investigation, how like how economically in the end the client, whoever the client is dealing, he want as less as possible, he want to spend the money as less as possible, for sure. So is it economical or not? How economically you can design the structure, design the foundation? So that it's very important. So this information we can decide based on the site investigation. Okay, these are the main purpose of the site investigation. Now, so what are the projects we can implement the site investigation? So it can be any projects, like any big projects, even for small projects we will do. Some examples of big projects, you can say high-rise buildings, telecom tower, or air traffic tower, cavity detection, and swimming pool, bridge constructions, dam construction, grade separators, landslide studies. So any slope stability investigations, for anything we can implement, for all kind of important projects we can implement the site investigation. Now here, as we are working in Mauritius, myself and my friend Mr. Shiva, so we are going to, here we are I'm going to talk about BS Grid Standard 5930. It is the code of practice for site investigations. Now there will be a question, why we have to follow a specific standard? Let me explain. Now let us say I will tell one simple test called SPT, standard penetration test. Okay, now as per the BS, this 5930, it is already specified how this test to be implemented on site. Let us say if we don't follow any specific standard, it will be party A doing the SPT in the site, and party B will be doing the this same test on the site in a very different way, in its own way, because party A may be thinking whatever he's doing is right, and party B will be thinking whatever he's doing is right, but it cannot be. For example, let us say as per the SPT, in general, as per the standard, it will be 63.5 kg hammer. It have the fall of 760 millimeter fall, and for every 150 millimeter the penetration, they will collect the number of blows. Okay, now let us say as I am a party A, I will, instead of using 63.5 kg hammer, anyway it's the hammer, I will use the 100 kg hammer to make sure it is to make sure the soil is very stiff. So accordingly we know that we will know which particular layer we get a strong density soil. In my perspective it is right, but as per the standard it is 63.5 kg. Now the party B, he is doing A, the soil is not that much stiff. Okay, even if it is stiff, but if I use the 50 kg hammer, it will take many blows. Anyway, if it takes many blows, it means the soil is stiff. So in my perspective, it's the right approach only. But in the end, they will not speak the same language, because for the party B, if he is using the 50 kg hammer, the penetration will be take longer than if 63.5 kg. And if I use the 100 kg hammer instead of 63.5 kg hammer, let us say with that particular hammer, the penetration with the standard hammer, if the penetration is 10 blows, as I'm using the 100 kg hammer, the penetration, the number of blows will be maybe only 8 blows or 7 blows. Now the N value is varied for the same kind of strata. So in order to keep everything, we speak in the same language, we have to follow a specific standard. So each country will have their specific standard for the site investigations. For here, they are following the code of practice for the site investigation, which is British standard. Okay, so whichever the standard you follow, the site investigation commonly will have 3 stages. Okay, one is reconnaissance survey, another we can say preliminary survey, and third detailed investigation. Okay, what is reconnaissance? Reconnaissance means in general you will do the site visit with careful inspection. Okay, then you will collect all the information and you will do the desk study. That is called the reconnaissance survey. Okay, so we will talk detail about the reconnaissance survey later. Then preliminary investigations. So in the preliminary, what they will do based on the reconnaissance survey and the desk study. So then, okay, let me explain. So reconnaissance survey, you will just go to the site. You will see what are the problems are on the site. Let us say you're getting the slope, or you're getting the drainage, or you're getting the landslide, or is the site is flat with no problems, or is there next to the site, whichever the building has constructed, is there any cracks on the building? So our building can also get the cracks. So this kind of informations can be gathered in the reconnaissance survey. And also you can come to the office, you will do the desk study. What is desk study? You will see, okay, what is the geological condition of this particular site? Is there any crater, or is there any other river is passing nearby, or all these informations, and geomorphological characteristics also you will know, like geological map. You will see the aerial map, like with the help of Google you can see what kind of other structures are nearby, and you will take soil map and you will check what kind of soil we are going to get in this particular project site, and did we do any other previous investigation around this around this particular region. So what kind of soil and rock properties we are getting. So all this study like before you start the investigation. So this is called, without doing anything on the site, this is called reconnaissance survey. Then preliminary investigation, based on your reconnaissance survey, you will do the okay, we keep this much amount of test points, we do this test as a to get an idea. That is called preliminary investigation. Detailed investigation, based on the preliminary investigation, we will do detailed investigation, for especially the projects like dam, reservoir. So this kind of projects are tunnel projects. We cannot do in the beginning itself. We cannot say, okay, 100 boreholes, we do it everywhere. No, we cannot take the decision like this. First, we will do the preliminary survey. After the reconnaissance survey, okay, we spread this borehole. Then we see, is there any big variation? If there is any big variation, we will, in the detailed survey, we will have many boreholes. And if there is no big variation, we will keep minimal boreholes in the detailed investigation with some chemical test if it is required. Okay, so in this kind of informations, we can do it in the detailed investigation. Okay, these are three main stages in site investigation, whichever the standard you follow. As per the British standard, here we are going to see what are the different stages of site investigation. First, preliminary considerations. Second, planning ground investigations. Third, field investigations, like it can be either geophysical or borehole drilling or trial pit excavations, or combine everything together. So generally in geophysical, what they will do, for example, based on the previous experience, we will know a certain region may have cavities, for example. Okay, so they will perform some kind of geophysical investigation to know where are the cavities available and what depth they are available. So they will do the cavity detection, okay, through some specific geophysical methods. Then once they get the result, they will know these are the places they are getting the anomaly. So those places specifically, they'll perform the borehole drilling to reconfirm these particular findings are matching with the interpretations or not. So they will perform the borehole drilling. If it is not deep, they will perform the trial pit excavations. Okay, in that way also we can identify if there is no cavity, or if there technically if there is or if they are sure if there will be no aquifer in that region, they directly go for borehole and trial pit excavation. Okay, then field test. What are the field tests? I already talked about the geophysical survey. It can be resistivity test or seismic method or ground penetration radar, etc. Other methods are also. Then borehole in-situ test. So borehole in-situ test, it can be a SPT, standard penetration test, pressure meter test, packer test, and we have other methods like cone penetration test and dynamic cone penetration test. We will see in the other few slides. Then trial pit in-situ test. In the trial pit also we will do some in-situ test, and it can be density test or percolation test or some other kind of test. Now, what is in-situ? It means in place. What does it mean? Without disturbing the soil, we naturally, what is the properties of the soil that we can determine on site? Okay, that is called in situ. Now, laboratory test. We will collect some samples, then we perform some lab test, then description of soil and rock of based on all these parameters. Then collect the data. We keep everything in the geotechnical report, and we'll interpret the data. Okay, these are the different stages of site investigations as per the BS. So, in the preliminary considerations, we will see, generally, we will see the suitability of the proposed work of the site for the proposed work. So, like I have already mentioned, can we do the construction here or not? That will decide. Then, will it be expensive or will it be within our budget? Okay, economical perspective. Then, will there be any potential issues are there? Okay, so that we have to see prior we perform any ground investigation. Then, will it affect the environment? For example, if you are going to construct any chemical factory in that particular site, now we have to see how far, if there is any river, how far that river from the site, and as per the law in that particular region, will it affect the environment or not? And what is the soil condition? What is the soil chemical properties? So all this we have to consider while we perform the site investigation. Then, what is the suitability? The site is suitable or not? That also we can determine. Then, what are the other existing works, which work is already existing over there, and how it can affect the future project? All these parameters should be considered in our preliminary considerations. Okay, so now in the preliminary, what works we will do? We will do the desk study, and we will do the planning the details of further investigations and reconnaissance survey. Regarding the desk study and the reconnaissance survey, we have already talked about it. And based on these two, we will determine what will be the further investigation required. That we will determine. Now, second, planning ground investigations. So, based on the preliminary considerations, we can determine, okay, for this is our project. For this project, we will need minimum 5 boreholes and 6 trial pits. And in the boreholes, we have to perform this many number of SPT. For example, this test we need to perform in the boreholes, and this test we need to perform in the trial pits because of these reasons. Okay, like that we will plan for the ground investigation. Okay, so that is the second stage actually. And also, if we need to know about the groundwater condition details, or if we need to monitor in future, that details also will be included in the scope. Okay, that is called planning for the ground investigation. Then, Now, once planning is over, like I mentioned in the very beginning slide, in the first slide, so these details will be sent to the geotechnical contractors, and they will quote, and once the quote is approved, then they will come and perform the field investigation. Now, you should remember two things. Either it can happen the way I was mentioning, the engineers will send it to the client's engineer will send the details to the geotechnical contractors, and they will then they will send the quote, and we will select one of the geotechnical contractor. Second, instead of contacting through the engineer, the client can directly approach the geotechnical contractors. See, this is my project. Propose whatever you think is important. Then the geotechnical contractor can propose directly. He will do all this reconnaissance survey and everything. Then he will propose what needs to be done, what is required for this project. Then once the client approves, then directly they will perform the field investigation. In this way also it can happen. Now, then field investigation, it can be either excavation or via drilling. In the excavation, the pros for the excavation is that in the excavation we can see the soil layer very clearly. Let us say minimum 2 meter by 2 meter, and depth up to even 4 to 5 meter also we can excavate with the help of the excavator. Then we will know different soil layer, if there is any 2 or 3 different layers. Definitely topsoil will be there. After topsoil, is there any 1 layer or 2 more layers is there, or many layers are there? We can determine. We can check. For each layer, the samples will be collected. Okay, it can be either disturbed or undisturbed. You will see that. Okay, see, like this, the expression will be there. You can see here. You can see here in the trial pit excavation, and inside you can see they are doing some kind of test. It's called percolation test. They will perform 30 by 30 centimeter hole. They'll pour the water, and they will check the infiltration rate for every minute. Okay, so this is called percolation test. This kind of test can also perform in the trial pit. And see here, this one you can see very clearly. So we are getting the stiff clay silt soil here after the topsoil, and that clay clay silt soil is extending up to, see, there's a staff here. Normally to measure the depth, we'll keep the staff, and we'll take the picture for pictures, and you can see. And if there is any percolation test required, then they will do this test. Mainly they will do this test to design the sewage. If there's any sewage disposal needs to be done in the site, in that particular location, they'll perform this test. Okay, sometimes we don't get the soil, we get the rock, so which is very good for the foundation for sure. So then we need to hammer it to make sure we are not getting the boulders until some 2 meter by 2 meter, and remove the soil up to 1 feet, 1 feet or 0.5 meter. Then remove the soil and take some pictures and do the logging. Okay, so this is called trial pit excavation. So either we can get the soil or rock. Then drilling. So in the drilling, we have different types of drilling. Mainly, we have auger drilling and rotary borehole drilling. So auger drilling, you can see here the spirals like this. It will just rotate inside the soil. It will just take the soil outside. Then it will collect any engineering geologist or geotechnical engineer. They will collect the soil in the sample bag and label it in a proper way, and they will give it to the laboratory. This is one method. But the drawback of this method is that if you don't get everywhere, we don't get completely soil layer. It's a mixture of boulders, or you can get the rock in between. Okay, so that's why this method is not applicable for all the regions. But another method is called rotary borehole drilling. This is a drilling rig actually. So in the rotary borehole drilling, we will collect the core samples actually. So the core samples, it can be soil sample or it can be rock sample, no problem. We can collect the samples and it will be placed in the core boxes as per the depth we have collected. Okay, so I'll show that picture. So in this way, in the same drilling rig, we can do some standard penetration test, pressure meter test, packer test with the help of after we do the drilling. With the help of drilling rig, definitely we do the standard penetration test. Sometimes even we do the like vein shear test. Many tests with the help of drilling rig we can do. Okay, so the size of the sample can be like 50 millimeter, 40, 55 millimeter, or even 70 millimeter, 90 millimeter, like so. Different size it is there. We have NQ, HQ, different sizes are there. Now, so it can be any tropical regions, or if it is any cold region, or whichever the region, it is possible this drilling with this drilling rig. Of course, when you do working with the drilling rig, you have to make sure you are wearing all the you are following all the safety measures, okay, with the helmet, safety shoes, and all. Now, based on the drilling rig, rotary borehole drilling, we collected the sample, and these samples will be placed in the core boxes like this. See, it is 5-meter core box. Each line it is 1 meter. So it will be when we collected with the core barrel, the samples will be collected in this way, and it will be placed in the core boxes, and they will label it in a proper manner as soon as they have collected. Okay, so here we can see many fractured rock. Here we are getting some good rock. Okay, so this will be placed. This is called core boxes. Okay, yes, I have already explained. Trial pits will be minimum 4 to 5 meter, a maximum of 4 to 5 meter. But the drawback is that with the trial pit, we cannot go deeper than that. But the good thing with the trial pit, we can see the soil layer very clearly in all 4 directions. But in the borehole, the sample is very small. It's very minimal. So like I was mentioning, normally they will do NQ and HQ, which means around 55 to 75 millimeters something. So it will be, the sample will be very small. Okay, so we will not have the big picture, but we can go deeper. Okay, that's why we'll need many boreholes to see the overall condition of the site. Now, based on the field investigation, the samples can be collected. This sample can be disturbed sample or undisturbed sample. For the rock, forget it. I'm talking about the soil. For the soil here, it can be disturbed sample or undisturbed sample. And in the boreholes, okay, in the disturbed sample, let us say in the trial pit excavation, as soon as you excavated, this excavated material will be saved in the sample bag, label it, and label it and bring it to the lab. Now, this disturbed samples, it will have the natural structure of the soil. Okay, it's a natural structure of the soil will get disturbed here. Okay, in the disturbed sample. Okay, but it will represent the composition of the sample. Okay, in the disturbed sample, but undisturbed sample, the natural structure will not get disturbed. Okay, that's why it is called undisturbed sample. Of course, some little disturbance will be there for sure, but that will be very minimal in the undisturbed sample. Okay, so then in the undisturbed sample, of course, the water content will be preserved. But in the disturbed sample, the sample is already disturbed. If it is left it for 2 or 3 days, the water content will be not the same. So immediately after the sample collections, immediately if we keep in the sample bag, then we can preserve the water content in the disturbed samples. Okay, in the disturbed sample, we can perform the test like grain size distribution, plasticity characteristics, and specific gravity. And in the undisturbed samples, we can know the compressibility characteristics of the soil. Okay, so how it can on the site, how will be the condition, that we can know because it's undisturbed sample. So compressibility characteristics, shear strength parameters, and permeability characteristics. These are the engineering properties we can determine from the undisturbed samples. And also, of course, we can do other index properties like disturbed samples, like shrinkage limit, and even same grain size, plasticity, specific gravity. These parameters also can be determined in the undisturbed samples. Okay, But this compressibility, shear strength, permeability, this can be determined only in the undisturbed samples. Okay. So this is disturbed and undisturbed sample. Now, field investigation. So the sampling and labeling should be, it is an example. You know, we are doing so much expenses to do this investigation, and we have to make sure these samples have been collected, labeled properly, and bringing it to the laboratory, or else it'll be wasted for the client. Okay, so we have to follow proper, even if it's water samples, it should be representative. We cannot just take some Coca-Cola bottle and fill the water in it. No, it will change the properties of the soil. So we have to take proper water container to collect the samples, and we can give it to the lab. Okay, so then like proper handling and labeling should be done. Okay, this is one of the example. You can see the project name and which location has collected and what depth it is collected. Okay, all this should be labeled, and see, you can, it'll be a like a sealed cover. It should be in this way. It's one of the example. It's a disturbed sample actually. Okay, then in-situ test. It can be any in-situ test, like a standard penetration test, cone penetration test, plate load test, sand replacement method, nuclear gauge density test, field event shear test, pressure meter test, open borehole test, like constant head and falling head, packer test, and percolation test. These are some of the important in-situ tests we used to perform on the site. Okay, so each one will give the one of the soil properties. For example, standard penetration, we will see. Now, standard penetration test. In the standard penetration test, we can determine the relative density, shear strength properties of the soil, and the bearing capacity of the soil. Okay, these properties will helpful in the foundation design. Okay, to determine the foundation design. Okay, then to the vein shear test, we can determine the undrained shear strength properties of the soil. With packer test, we will know the permeability characteristics of the rock. Packer test. And pressure meter test. With the help of pressure meter test, we will know the stress and stiffness characteristics of the soil and strength characteristics of the soil. Okay, and density test in trial pits. So with we have the method called sand replacement method. We will know, with the help of sand replacement method, we will know what is the density characteristics. Sometimes this method, this sand replacement method, if we do any engineering field, if we compacted during the road construction, we will know, like based on the lab test and the field density, we know how much compaction has been done now, and will it be like, did it meet the requirement or it did not meet the requirement. Accordingly, they will determine, no, the compaction is not enough now, you have to recompact it now. So this kind of decisions can be taken based on this sand replacement method. Okay, so these are some important institutes. I will just explain some tests. So SPT, there will be a hammer. I was telling, as per the BS, it's 63.5 kg hammer. There is an anvil. They will lift and drop, lift and drop. So this will be 760 millimeter distance, and this in the bottom, the SPT shoe, it will penetrate in the soil for each blows. For each 150 millimeter penetration, they will take the N value. So they will penetrate up to 450 millimeter. The first 150 millimeter as they will consider as a seating depth. They don't consider. Then second 150 and third 150 millimeter, they will consider the N values, the number of blows. Then that will be the N value of the SPT. Based on that, we know the density and relative density, and we can determine many parameters with this SPT N value. Vein shear test, it will be like a blade, like this kind of blade, cross blade, and it will be pushed in the soft soil. It is not applicable for the sand or gravelly soil, only for the soft soil, not even for the stiff soil. So they will push in the soil, they will turn. There will be a torque meter. Based on this, they will know the undrained shear strength properties of the soil. Pressure meter test, it's kind of a rubber membrane, will be inserted in the soil. This rubber membrane will be expanded. The surrounding soil, if it is a soft soil, it will easily expand. If it is stiff soil, it will resist. Based on that, we will know the stiffness and strength parameters of the soil. Okay, So these are the tests we will perform in the boreholes, and SPT I have already mentioned, explained. You can see like SPT hammer, drop, and every 1.5 millimeter they will take the reading. SPT split spoon. Previously, it was the human was lifting and dropping. Nowadays, we are getting the automatic. Okay, this is called plate load test. It is to know the loads. Based on the plate load test, we can know the bearing capacity and the settlement characteristics of the soil. There will be a plate. It can be 300 or 600 or 750 millimeter diameter plate, and it will be loaded. So then, accordingly, we will know the settlement characteristics. The load versus settlement curve we will draw. Based on that, we can know the bearing capacity, settlement, modulus of subgate reaction. These parameters we can determine from the plate load test. Then borehole test, it can be like a constant head permeability or a falling head permeability test. In the constant head permeability, let us say in the borehole there is a water, and what they will do, they will make sure the water is constant. They will again and again they'll pour the water. They, before they start the test, they will check the water level, and they will pour the water, and continuously the water they will make sure the water is maintaining the same level. Okay, so constant, that's why it's called constant head test. The constantly the water level will be the similar in this test, and based on that they will know the permeability. Now falling head test, there is no water here. When you pour the water, for example, if you are going to do the test in this particular section, they'll pour the water here. Okay, if you want to know the permeability of this section, they'll pour the water. They will see how much time the water is going down. Based on that, they will perform 3 tests minimum. They will know the permeability. We can determine the permeability characteristics. So as the water falling down, it's called falling head test. Okay, then packer test I was talking about. So packer test, what? So once you finish with the borehole, let us say if there's a rock here. Okay, we don't know the how many cracks are in the rock. Okay, the rock have the fissures. So what they will do, let us say they have done 0 to 5 meter. Okay, then let us say this particular 2 meter section, for example, we want to know the permeability. They will install the packer. It's like a rubber membrane, rubber tube, you can say. Then it will have the expansion properties, where when it expand, it will block the wall, and it will not let any water go away. Then the water will be pumped inside. Then they'll increase the pressure on the top. So this, due to the applied pressure on the top, the water will penetrate. If there is any crack, it will go inside the wall. So based on how much for each pressure, how much amount of water is going, they can determine the permeability of the soil. Mainly this kind of packer test will be applicable in the dam or reservoir area. Okay, so it can be single packer or it can be a double packer test. Okay, so this is one of the packer tests to determine the permeability. Then after all these things, we have to determine what is the groundwater on the site. Okay, so with the help of a water level indicator, we call it as a dip meter. This will have the sensor in the tip. When it touches the water, it will give a beep sound. So based on that, we will know what is the depth of the water level. Okay, sometimes to monitor the water level, what they will do, they will install standpipe PVC. Okay, slotted one, because if it is not slotted, the water cannot penetrate if the bottom is blocked. That's why they will slot it. So it's a plastic PVC pipe. Then they will install, they will cover it on the top with a cap. So whenever they want to know the water level, they'll open the cap, they check the water level and close it again. Okay, so that's how we monitor the water level. Okay, so this is groundwater monitoring. Then lab tests on the sample, we already mentioned that the sample should be representative, and we have different lab tests. Natural moisture content, Utterberg limit to know the plasticity characteristics of the soil, grain size distribution, how fine the soil is it fine grained or coarse grained? Hydrometer analysis, if it is very fine soil, how much percentage of clay, how much percentage of silt is there, we can determine through hydrometer analysis. Specific gravity of the soil, and direct shear test, triaxial test. So it can be unconsolidated undrained, UU, CU, consolidated undrained, or CD, consolidated drain. Then we will know the UCS, unconfined compressive strength of the soil. Based on this UCS also, we will know the shear strength properties of the soil. Then consolidation test to know the compressibility characteristics of the soil. Okay, these are the common lab tests we will perform. Rock test, it is a UCS, unconfined compressive strength test, and plate load test. Okay, then description. So we collect the sample and we place it in the core box, or we do the trial pit excavation. Now we have to make sure this sample will be described in the report in a proper way. It is in the report, we call it as a logging, which means we will log, we will analyze the soil and say, okay, in the soil we are in the site we are getting, in this particular trial with 0 to 0.5 meter, we are getting the top soil, and this is the color, texture, and how it was. This much amount of rootlets were there, and how it was. And if it is then layer 2, what is the soil property? And whatever the description you are giving, it should reflect on the site. That is very important. And as per the standard, different standard, and mostly all are same, and with little variation. In general, you will give what is the density properties of the soil, like consistencies, a very soft, or dense, very dense, this kind of characteristics. Then what is the color of the sample, and what is the plasticity characteristics of the sample. If it is from the trial pit, we will know the moisture content, like it's slight moist, dry, you can keep. Then what is the main soil type? Along with the soil type, is there any other third like gravels or boulders are there? And is it what is the origin? What type of deposit it is? Is it a residual native soil, or it is a transported soil or fill material? You can keep this information. And what kind of classification is high plastic soil, like MV, CV, like that? We will have some kind of code, okay, letter code, so to represent the soil. These informations we can provide in the description, okay. And it shouldn't be like a paragraph and paragraph, okay, like two or 3 page or half page. No, just a small, simple 5-6 lines maximum, or even if you can shrink it, that's much better. But it should have this information. Okay, so these are some important informations about the site investigations. So now I'll invite Mr. Shiva to continue with the report preparation. Thank you so much.
So can you kindly provide us with this PPT?
We will provide with relevant information to you. Okay.
Okay, so thank you.
Yep. Okay.
I can go ahead. Hello.
Yes, please.
Hello everyone. My name is 𝗖𝗂𝗂𝗿𝗀. I'm going to present how to prepare a geotechnical report. Karthik, next slide. Yes, this is the outline. Usually in the report, we used to describe scope of investigation, description of the proposed structure, and scope of works, and site features. We need to consider the geology and number of borings or investigations like trial pits, depth of borings, and general description of the subsoil conditions, and in-situ testing and lab tests. We need to consider the groundwater conditions as well. In the report, we are going to give the recommendations of the foundation, including the type of foundation, either it is shallow or deep, or any slope issues, or any underground excavations. And also we include the conclusions. Karthik, next slide. Yeah, actually I'm showing a template. It's I just extract from one of my report. It's the cover page of the report. Usually we have to concentrate. The first page is the main. It gives an idea. We have to include the title of the project, relevant project photo, and the client name and your firm name, if you have any logo, and you can display, you can include in your cover page, and date as well. Next slide. Next to the cover page, usually we include the client address and who prepared the report and issued. It should be checked by and reviewed by another engineer, so that it is better. You can reduce the errors of the report, and you can keep the document revisions and date of issue, because once you issue the report, maybe the client have request some changes in your report, you may have to amend. It is better you can have a revisions and date of issue. Next slide. Actually, in geotechnical report, we have to mention about the executive summary of the report. It's like a single page or 2 page, maximum 2 page, not beyond. We just give the summary of the whole report. Like we just give a small project description, scope of works carried on site, and strata encountered on site, and in-situ testings and lab tests. Not in detail, just give a outline, and what is the ground profile, and if we have a bearing capacity and settlements for the footings, or any slope stability and factor of safety, and we can include the recommendations as well about this page. Just an outline, we have to give a summary of the whole report. Next slide. We have to include the table of contents and list of tables and list of figures. Next slide. In chapter 1, we have to give the introduction. It should be like a 1 page or 2 page. You can make, you can minimize. It's better 1 page, single page is okay. You can prepare. You have to give the description of the project and the client and date of award. And if you have a layout plan of the project, or you can include in the introduction, and you can mention the scope of works. Either the scope of works given by the client, either by client or consultant or the design engineer or the geotechnical contractor. We have to mention what scope we are going to execute for the particular project, either trial pits, core holes, in-situ tests, lab tests, and reporting. Sometimes you may need geophysical also. If you are going for a dam project or any high rise, any large scale project, you need to go both geotechnical and geophysical investigations, which is required. And you can mention about the report format, that desk study, geology, groundwater. Just an outline, description of field works, in-situ and laboratory tests, photos and logs of trial pits and core holes, and interpretation of the data. Next slide. Yeah, in chapter 2, you're going to brief about the desk study information. That means you should mention about the site location. Where is the site located? How much far from the city or village, or maybe it may be in the forest, and what is the topography? Either it is flat or undulating or sloping ground. We have to mention. Sometimes before the start of projects, some clients may do the survey. Then you can get the contour plan, so that you know how the site condition is prior to your investigations. You have to collect, you need to do site reconnaissance. That means collecting the site data, site features, by taking photos and recording if any failures or any unforeseen conditions, you can see any buildings nearby or any. You have to record how is the site condition, and you need to record. Then site history. Actually, we used to take site history based on Google Earth satellite images. It's a free application, anyone can use. Based on your local context, you can check your site condition. Okay, from the past, maybe you can get up to 20 years, I think, how the site has changed with the time in the vicinity of the site, what developments has made. You can check everything from Google Earth application. Then we will describe about geology, soil map and hydrological map of the site. Next slide. This is a template. Usually we it's a Mauritius. You can see it's a small country. We indicate the site location. We indicate the site location and topography, and we have some digital map we shown, and Google Earth. We use Google Earth, and some of the site photos in directions east, west, north, south directions, how the site looks. And this you can see the site history from the past, from current to the past. You can consider what is the variation. From the satellite imagery, you can know what are the changes to the site. Next slide. This is we describe about the geology of the site and soil map and hydrology. You can get this information in public domain. Sometimes you need to buy the information based on your site condition. Okay, this is for up to chapter 2. Now next slide. Chapter 3 consists of field and laboratory works. In this chapter, we are going to define what are the investigation works we carried on site, like either trial pits, core holes, in-situ tests, lab tests, and we need to mention for the excavation of trial pits, which type of equipment we use, and how many numbers. What are the coordinates? We have to do the survey also. Actually, you can use the Google coordinates also to locate your position, and depth of excavation and sampling. Either sampling may be disturbed or undisturbed sampling. You can record the depth of samplings and all. Already Mr. Karthik already explained how to sample and how to label as a record. We have to mention in the report. Even for the rotary core drilling also, what type of drilling rig, either it's auger type or rotary type, how many core holes we drill, what is the coordinates, what are the locations of the core holes, and UD sampling is undisturbed sampling, which you can use for triaxial testing or consolidation or any other testing. You can use undisturbed samples. And in-situ tests. In-situ tests, so you have many types. In the core hole, you can do SPT, standard penetration test, which gives you the consistency of the strata. Actually, in BS 5930, we have based on SPT, we have consistency for cohesive and cohesionless soil. For cohesive, it's very soft, firm, stiff, very stiff, based on the SPT values. And you have for cohesionless soils, you have very loose, medium, dense, very dense. It depends on the consistency. And the pressure meter, you can determine in situ stress parameters. And the DMT, dilator meter, even these also, it's in situ test. You can do in core hole, CPT, cone penetration test, percolation test, and so on. We have many varieties in situ tests. Based on the scope, we have to, we can include in your report. Then we have lab tests. Here we will mention the quantities and the standards adopted. Based on your local context, you may use Indian standards. Someone may use Australian. Here in Mauritius, we use British standard and some ASTM also, American. Next slide. Yeah, you have various standards. Based on your context, you can use the standards, and you can mention which standard you are using for the testing. Next slide. Yeah, chapter 4 consists of results and ground conditions. Whatever investigations we done, for example, if we do trial pit or core hole, we have to define in a summarized table. I just kept like a sample table. Here we mentioned like 2 core holes. You have a cavity, topsoil, and a highly weathered basalt. The strata and the thicknesses of the strata I mentioned here. For example, if topsoil, I took a ground level as a 0, and from 0 to 0.35 is the thickness of the topsoil. In another core hole, I have like a 0.5 meter. We have to define, okay, in the profile description, I need to define, okay, topsoil, I have the thickness varies between 0.35 to 0.5 meter maximum, and what is the color, what is the texture, if any presence of gravels or any rootlets, organic matter, or any contaminated material, we have to describe. Like it should be 4-5 lines only, not too much. As Karthik already told you that we have to describe in a small paragraph, that's all. For each strata, we have to define. For example, highly to moderately, the thickness varies between 0.35 to 2.1 meter. Yeah, it changes. We have to describe in the profile descriptions. Then we have to include the in-situ test and and the results and graphs also. You have SPT and PMT. You have so on many in-situ tests. You can include the results here. And if you encountered rock, you can include the RQD with respect to the depth RQD table. And actually, RQD is rock quality designation, which you can use for the, it will be helpful for your tunnel, or if you do some tunnel projects or any pile foundations, it can be helpful. Then you can include the lab results and the groundwater. Next slide, Karthik. Yes, actually, I'm just showing a template here. We indicate the SPT values with respect to the depth. We have different core holes here. You can see different core holes with respect to the depth, how the SPT blows varies. And this one also, the second graph is SPT value with elevations. The elevations of the core holes may not be the same. It may be, it may change the elevation, the height. With respect to the ground level, we draw the SPT and value variation. This one, this is a pressure meter results, Maynard modulus, which you can use for the calculating the settlement criteria, you can use these stiffness values. This one drawn as per with reference to the depth. You can see the depth in y-axis and Maynard modulus in x direction. Next slide. Actually, this graph is for groundwater monitoring. Actually, we install in two core holes. We install the standpipe for groundwater monitoring. We kept a probe. We install a probe and leave it for nearly 2 weeks. Then you can see the elevation of the groundwater with respect to the elevation, how the water fluctuates with the rain. Initially, it was like a 3 with rain, and it changes. You can see you have 2 piezometric readings in CH3 and CH13. This one will help during your construction stage. Maybe if you have a deep excavations, you can know whether if you need any pumping or pumping required, or any tunneling also. You have to dewater. That's why you need monitoring of standpipe piezometers you require. Next slide. In chapter 5, usually we do geotechnical engineering assessment. In this chapter, we are going to interpret the soil profile, and we are going to assess the soil profile based on the core holes drill, based on the investigations, and we are going to define the properties based on in-situ tests, lab tests, and correlations. Then we can use that information for calculating bearing capacity and settlements, either by hand calculations or analytical methods. Any other, if you have any software, you can use, and we can include the foundation recommendations with the excavation details. What is the depth of foundation? Either it is shallow or deep. You are going to, if you require shoring, if you require any dewatering, or we have to mention, and references. We need to include the references. Next slide. Yeah, actually, this is one of the project. We drill some core holes around the site. We have like 4 plots of the land, and we made some section. Next slide. Yeah, in this profile, actually we took the core holes, all core holes, and we try to arrange in a section. We draw some section, and we mention about the this blue color is rock level, and this all yellow color is clay weathered basalt, and we define the layer thickness based on the strata encountered, and we try to define the groundwater level, and where is the foundation basement level we define. Even we try to trace this SPT values, how it is varying with respect to the elevations. You can do it in Excel sheet also. Actually, this one we use some software, and we try to get generate the section. But you can use Excel also. Excel sheet, you can define your profile with respect to the elevation, and you can adjust the distance. Next slide. The software we use a hole base. It's a Bentley hole base. In the appendices, we are going to include the trial pit photos, logs, and with the descriptions of the strata and the photos, core hole logs and photos, and in-situ test results, either SPTs or pre-MT, DMT, or CPT we include, and lab results, laboratory test results from the, we can include the certificates and the hand calculations, any software output. Next slide. I'm going to show some of the templates. This is the trial pit log. You can see a guy holding the staff. You can measure the depth and the topsoil, and usually whenever we excavate the trial pit, we try to take the 4 phases, how the strata is it's uniform or any changing. We have to, you can mention the direction of the trial pit. Okay, it's in the north direction, the face is like this, and the east direction, east, west, south, you can indicate, and the depth of trial pit, and the layers also you can describe. You can see here in the log, we have two layers, 2 different layers. One is maybe topsoil, and one you have like this color. You can indicate the color also. Actually, it's a software generated, but you can do in Excel as well. Initially, we use Excel. Later, we change to software. Yeah. Next slide. Yeah, this is for the core hole. We arrange the core recovered when we drill. We recover the sample, and we kept in the core box. This is a 5-meter core box. You can see these are the separators. These are the core runs from 0 to 1.5 meter. The first core run is 0 to 1.5. From 1.5 to 2. This is an undisturbed sample. It's a tube sample. Actually, it's a U2. Actually, the number indicates the inch only. U2 means 2 inch. That means the diameter is 52 millimeter. 3, you will have U3 also. U3 means 3 inch. It is like a 76 millimeter. U4 like a 100 inch. Sorry, 100 millimeter. U4. It's 4 inch. It's 100 millimeter. Likewise, you can see the core run also 0 to 1.5, 1.5 to 2 to 2.5. We indicate the SPTs also. We mention the blow count and the recovery, and we pack it in, we wrap it in plastic bags. Yeah, we can mention like this, and this is the log, core hole log, and actually it is not the same. It is different project. The photo is different and the log is different. You can mention the core hole log with the different colors, and the core run, and the SPTs, and U2, and you can indicate based on the strata encountered, and you can give the coordinates of the core hole location, start date and end date, and the final depth. If you encountered any groundwater, you can mention the groundwater, the diameter of the sample, you can mention. Next slide, Kathy. This is the sample project. If you have a different investigations, like you have different core holes, you have different positions. You can see the contours are it's a like a sloping ground, something sloping. It's then you can draw a section. You can consider a critical section if you have to do the slope analysis. You can try to take the core holes where you have a like a critical section. You can analyze that part. Next slide. You can indicate the core hole logs also like this. For example, if you take a section, you can indicate the strata, how it is, the layer thickness also, the descriptions, everything you can mention like this. Next slide. You can like a some sketch also you can make with hand also. It's not any, you can draw some hand sketches, how the thickness varies, and you can draw like a, even you can use a graph paper, and in Excel you can do it, the thickness of the strata, topsoil, alluvium, residual soil. Yeah, you can indicate, which gives you an idea how to do your foundation at what level, and where is the groundwater, and you can show everything. You can consider all these parameters for your design of foundations and sizing. Yeah. Next slide. Yeah. Next slide. Yes. For example, sometimes you have many layers also. You have, for example, here 2 core holes. The thickness may changes, and you have like a 0 to 0.5 meter. You have sand, then clay. The clay thickness is higher in BH4. Like this, you can also you need to interpret the information, whatever investigations you carried. You take the data and you try to interpret the information. Yeah. This is a profile for the calculations, for the interpretation. Yeah. Next slide. I think my topic is finished. I think thank you all for listening. Thank you, Bhavanam, giving such an opportunity for us. I think I try to finish. I try to finish in the quick because it's already late. No, that's why.
We can understand, sir. That's thank you so much, sir. You, Karthik sir, and you provided wonderful information for the geotechnical engineers and some structural engineers and some students also. So it's we felt like it's a very knowledgeable session. So thank you so much. So yeah, we can allow this for a question and answer session.
Yes. Yeah.
Okay. Yes. Any questions? Yes.
So I have a question.
Yes.
This is Karthik. I have a question. For the mining sites, will the falling head test will be applicable in case if the ore is like at very shallow depth?
If the hole is shallow depth, sorry, can you repeat
The ore. The ore.
Ore. Okay.
Okay. Ore. Yeah.
Okay. Ore mineral. Okay. Anna, yeah.
Actually, I just want to know for the falling head test. Usually, we try to calculate the permeability. You need the permeability of the strata. That strata you want, Karthik? Hello.
Yes, sir. Yes, sir.
No, you want to calculate the field permeability of that strata.
Okay.
No. I'm asking you.
Yeah.
Oh, no. Okay. So when I was doing my internship at a mining site, so they were using the falling head test. So that's why I was, because the ore was just the ore was only 1 meter below the ground level.
Okay.
Yeah.
Actually, falling head test we calculate to check the in-situ permeability. To calculate the permeability, maybe
like
they want to check.
Yeah, I'll rephrase my question, sir. That would be easier. Is there any other test which we can do to investigate the soil, or check whether the foundation is suitable for drilling or for extracting the ore when it's at a very shallow depth? Like, for example, if it's only 1 meter or only 2 meters below the ground level. any test we can prefer?
Basically, for shallow investigation, you can do a trial pit, and you can collect the sample, and you can check whether it's if you are doing for a mining, and you can collect the sample and check chemical analysis, and also I think the permeability test why they done. I think they want to check whether in future, if they do the extraction, if any groundwater or rainwater, it infiltrate and it can contaminate nearby rivers or groundwater. That's why they check that falling head permeability, I think, in my opinion.
Okay, thank you, sir.
And I want to add one more point along with Mr. Shiva's explanation. So actually, if you are going to construct something in this mining area, we have to make sure the groundwater condition, it is because normally in the ore, especially in the mining of ore, this ore mineral sometimes it can mix with the groundwater, and sometimes it is not this groundwater you cannot use it for any drinking purpose. Okay, so before we do the construction, we have to make sure it is because people, if the people are going to live in the nearby mining areas, we have to make sure how it will affect the people if they consume this water. Will it give any any kind of disease, or how? So all these parameters should be considered, like even environmental perspective, how it is going to impact the surroundings. Everything should be included. So yes, especially in the mining area, it's kind of critical. But like Mr. Shiva mentioned, they
Water
may
is
they
the
may
transporter. Yeah.
Yes, what is the main transporter? Yes.
Yeah, it can
Yes.
transport that contamination near the water sources or something, so that it can contaminate. That's why maybe they check the falling head permeability test.
Yeah. Okay. Is it fine? Any questions?
Thank you, sir.
Yep.
Sir, this is what, sir?
Yeah.
Sir, actually I have one question, sir. Sir, is there any thumb rule for providing the boreholes at the site?
Is there any thumb rule? No, there is no specific thumb rule. Actually, it depends on the project scope. For example, if you're going to construct a building of like an apartment, only within the apartment, okay, they'll spread the boreholes mainly to, one or two boreholes or three boreholes if necessary. We no need to do 10-15 boreholes, because if while you're doing this investigation, that's why I mentioned, is there any additional investigation required? So if you when you do these 2 or 3 boreholes, if the soil represents the same, that's fine. If there is any big change in the soil in different boreholes, then we may have to propose some additional boreholes to make sure where it is this kind of changes are happening. You understand? So that's why it depends. Yes, Anna, sorry.
I can add some point. Actually, if your foundation size is some B, you can go 2 times of B, because the influence can have up to 2 times B. It's a thumb rule you can consider for the investigation. It also depends on the type of structure also. What is the your allowable settlements, and you need to consider. For example, if you're doing a water retaining structures, the settlement is very we should consider very low settlement considered to a normal residential building. You have to consider all these factors when you do the investigation.
Sir, actually I can hear based on the square feet area. actually for based on the plot area, the number of boreholes
Yes.
has been defined like that. Is there any provisions like that?
Can you repeat?
So based on the plot area, suppose if I am going
Yes.
to based on the plot area, is there any provisions for providing to increase the number of plot boreholes like that? Is there any provision?
I already told you, no, it depends on the type of foundation. For example, you're going to construct like a apartment. Let us say you are going to construct an apartment, and you may assume like a apartment of ground plus 3 or something. It's better you can go like the width of the foundation. Sometimes you may go raft also. Usually we should go like a minimum 10 meters for apartments, a minimum 10 to when you go apartments of high rise, you will go much deeper. And the numbers you can, if it is a flat area, you can consider like a 5 points. 5 points, or it depends on the area of the plot also. If it is a small plot, then you can go like 2 core holes or something, 2 or 3, which gives you an idea. For example, if you drill 2 core holes and at the extreme corners, you can do the 2 core holes and see if the strata is similar or changing. You can identify the profile. If it is changing, then you can go for another additional core hole. Like that, you can do during the investigation stage itself.
Okay, thank you, sir.
Excuse me. Good morning.
Yes.
What should be
Hi, good morning.
between railway line for residential building?
Thank
Yes,
you for
yes,
your
Mr. Abbas.
presentation. Thank you for your presentation, Mr. Shiva. Please, I saw some geotechnical report mentioned the bearing capacity without determining the foundation size. Maybe use. Can you explain something about that? Determine the bearing capacity without
Yes.
give any information about the size of the foundation, dimension of the foundation. Because bearing
Yes.
capacity, when you want to determine the bearing capacity, you need to know the size.
Yes.
Yeah.
Yes.
It's correct.
Yes. You need to consider the foundation width, and yes, it will have influence also for the settlement also.
Yeah.
You need to consider the sizes. Yes.
But I saw some report without mention to the dimension. It is
No.
how you can
No.
no. Okay. I agree with you. I agree with you.
Yeah.
The second question. Can you determine the depth of the borehole about the number of the storage? One floor, 2 floor. It's
Yes.
maybe if I have 5 building
Oh,
with
5 floors.
5, yeah. How much I need to make the borehole?
Actually, as earlier I told, usually we go if you are assuming a foundation size, okay, if you are considering like a 3 meter your width of the foundation, then you need to go like minimum 2 times of width 2 to 3 times you can go on the width of the foundation, and it's a thumb rule. And even if you are going for a ground plus 5 story building, you can as I said, you can go some like 10 to 20 meters. You can do like 2 core holes at the extremities of the development or apartment, so that if the strata is similar, then it will be enough. Or if any changes or any unforeseen conditions, then you can do some additional investigations during the investigation stage itself.
Thank you so much.
Yeah.
Thank you.
Yeah. One point I want to add. So this 2 times of the depth of the foundation. So it will be like from the depth of the foundation. For example, let us say if you already considered, okay, approximately your foundation will be 2 meters from the ground level. So you should not consider only if the width of the foundation is 3 meters. You should not consider only 6 meters. You should consider minimum 8 meters, 8 to 9 meters. That's better. 9 meters is better. So because your foundation can be plus or minus actually. So it's better to go at least 1 meter.
But also I think depend about the stress.
Yes, the influence can have 2 times the width, the stress influence. Yes.
There is any information about the stress for 1 building or 2 building, one store, second store?
Yeah, I can send you. Let me have a look. I think in ICE publications we have. Yeah.
Okay, thank you.
I think we can share. Yeah, no problem.
Thank you. I appreciate your this. Thank you.
Yeah. Welcome. Sir, if you have only full coring data, can we get some parameter about rock properties without supported from lab test data? Thanks. For CRI, if we have only full coring data, can we get some parameter about rock properties without supported from lab test data? Actually, if you have a geological hammer, you can test it's also a thumb rule. You can check the strength, how many blows you can break the rock, and you can give the strength. Then you have some tables also. Okay, in 3 blows, it's like a medium strong, or you have to check with a proper geological hammer. Then you can consider the table. Okay, in X blows it's breaking, in 1 blow it's breaking, means it's weak, weak to very weak, medium strong, and you have the strength UCS parameters according to that.
It will give you some idea.
Yes. Sir, can you guide me on steps I take in the future as to get your as a geotechnical lab engineer?
Sir, sorry for the so
yes.
Hello everyone. So we just keep the feedback link in our chat box. Please go there and give your valuable feedback on today's session, so that we can improve better things for the next upcoming webinars. Thank you.
Yeah. If you have any questions, you can send us a mail. Yeah.
Sir, please, if there is no problem, please try to give us the mail IDs also, so that they will contact you through mail.
Yeah.
Chat box you can. Yeah, not individual people. So sir posted mails in a chat box. Please try to take those mails, and you can get back to us if you have any further queries. Still, if you have any questions, please try to ask here, so That's so we do have an extra 5 minutes. We are here to clarify all your queries.
I think from you, I don't know his full name. It's mentioned you. Just mentioned about the geotechnical lab engineer. But normally, if you are interested in the geotechnical, they will give you some training. If you are the civil background, anyway, they will give you some training in the lab. Then slowly you can gather your informations and you can get the knowledge. Then it should be fine. Now, if you want to add some more points, you can add regarding the geotechnical lab engineer. Normally,
yeah, okay.
in your So,
Yeah, you can
any other
continue.
questions? Yeah. Okay. Any other questions? Okay, the report
Philip, I think we use the whole base software, whole base.
and
You can use
𝗂𝗏𝗀𝗄𝗧. Yeah. Sorry.
for training to become geotechnical NPTEL. Yes.
And 𝗂𝗏𝗀𝗄𝗧, he asked. Yeah. So his report also includes the proposed improvement techniques or only the field and lab test? No, the report will include, like we have mentioned, normally we have two, factual and interpretation report. So this factual report means it will have only the main information about the field and laboratory. Nothing will be there. That is a factual report. Interpretation report, it will have the recommendations and if there's any ground improvement techniques are required in that particular site, then it will be also included in the report for sure. I think it's for Abhijit. Railway line for residential building. I think we have to see the code. It will be mentioned in the standards. So if normally there will be a standard like it should be maintained in this particular distance or something. So as per the standard procedure, you have to follow. You can contact the ministry. They will give you the details. Okay, any other doubts?
What type of sample quality we are getting for SPT? It will be disturbed only. It will be a disturbed sample. Any other questions?
Sir, actually, I have a request. So, if you don't mind, can I show them a geotechnical course from our Boundary CTC? Sir, and
yes, of course, no problem.
Yes, yeah.
Yeah, thank you so much, sir. I'm just okay. Yeah, Venki, can you make us a co-host? As a host. Yeah. So meanwhile, you can take the notes. Hello everyone, can you able to see my screen? Can anyone please do?
It's showing screen sharing, but I couldn't see anything. Okay.
Is it, sir?
Yeah, now we can see. Yeah, now we can see.
Okay. Hope a few people are asking about the geotechnical course. So actually, we do have one course, particularly on a geotechnical. So the course name itself, geotechnical theory to practice. What is main about the geotechnical theory to practice course? While we are in a BTech or MTech, we always stick with our theory. But coming to means while we are in a labs, so at that time we will do some practical things and we will do the laboratory test. But coming to the out of the college, we need to perform some practical issues. So there we need to study more on geotechnical parameters. So otherwise, we may not get a clear understanding about what's happening in a soil apart from what we learn in a theory. So that's why we prepared a particular course on geotechnical theory to practice course. Why we prepared this course? While in the while in a civil engineering industry, so we didn't see some things some courses on really in a geotechnical. So that's why we take an initiative and we prepare that. In this course content, you will learn about the fundamentals of soil mechanics and important topics and backbone of geotechnical engineering and principles and design of reinforced earth walls and applications of geosynthetics and rock mechanics and tunneling, how you can design a tunneling, how you can detail it, and how you can study the tunneling. So the finite element method in a geotechnical engineering, some type of softwares also we will use in this PEM concept. So how we will use those softwares, and so those things also we demonstrated here. And sheet files and retaining walls and slope stability analysis and structural design of foundation and retaining structure and dynamics of soil and foundation, installation techniques and design of soil edges. This is the complete course. Actually, this is the main topics in our course. We do have some subtopics also. So coming to the course, if you want to register, and this course is presented by Dr. Mainak Mazdoor. He is an engineer and research manager at L&T. He is a PhD. He completed a PhD geotechnical engineer from IIT Kanpur. He is IIT Gold Medalist, IIT Kanpur Gold Medalist, and also he secured a Air 197 in GATE 2011. So he's taking this course and he is giving a value sessions in our course. If you are interested, please get back to us, and so there you will get some discounts also. Hope this is a course we made it until now. So if you felt like it is useful for you, so definitely you try to contact us, and I will share with you the details in our chat box. Please get back to us. So hope it's fine. So thank you so much. So yes, sir. Still, you have any queries, please let us know so that we can end up this one. Hello, everyone. Do you have any queries?
Okay, so if there is no query, okay, we can finish this session. And so thank you everyone for participated, and I hope this was helpful to you. Somehow it may be helpful to you. We hope so. And thanks for this opportunity to Bhavanam as well.
Yeah, it's very helpful, sir. Thank you. Thank you. It's not a hope, actually. It's a very helpful session. So yeah, both of you gave a clear information on how the geotechnical. So in previously, we also didn't see this kind of complete starting to ending, like where we need to study on a geotechnical and where we need to end up with our report. So this is the main thing we need as a geotechnical engineer need to know while we coming to study even the structural engineers also wanted to work with the geotechnical reports and everything. When I seeing these things as a structural engineer, I felt like whatever the things we are studying while we are designing the foundations. So we need a structure, means geotechnical data. While seeing the 𝗖ًcy lecture about the report profession, I seen that I revised some of my reports also. So it's a very knowledgeable session. Thank you so much on behalf of Bhavanam's team. So yeah, I hope we will do in more things in upcoming days. So thank you so much, all of you, to participate in this session and make it happen well. So thank you so much, and hope we will see you in our upcoming sessions. Please stay with us. We will come up with some more industry-related topics. Thank you, 𝗖𝗂𝗂𝗿 sir. Thank you, 𝗏𝗏𝗧 sir.
Yeah, thank you. Thank you so much. Thank you all.
Sir, we will end up this session. So
Yes. Okay.
Okay.